Oh hey, welcome to Rad Lab. So there's this YouTube channel that I watch sometimes. It's called Braille Skateboarding, and they have a series on there called You Make It, We Skate It. And basically people can make like crazy skateboards and send it into them and they'll just try to skate it. And people have sent them like some crazy skateboards, like skateboards made out of concrete or skateboards made out of rebar. And lately I've been kind of getting into electronics a little bit, like Arduino and stuff like that. So I kind of wanted to combine the two and make a skateboard for Braille that has some kind of electronics integration. So what I'm thinking to do is to make a skateboard that can time how long you do a manual for, and then at the end of it, it would tell you how long your manual was in seconds using like a voice or something like that. So anyways, that's just what I was thinking. So let's get started. After pondering about it in my garage of solitude, I decided to hop on the computer and start with the CAD model. Here I'm using a program called Fusion 360. I love using CAD models in the beginning because it helps me to plan out everything that I'm doing and with a high level of detail. Skating can get way intense, so I wanted a way to protect the electronics. And so the way that I wanted to do that was through the use of these aluminum guards. I was going to 3D print them, but I knew 3D prints wouldn't be strong enough to handle the savage moves of the Braille house. I did a ton of CNC machining and CNC programming in my undergrad, so I called back on those skills to make these sick guards. Once you kind of know what to click, CNC programming is not too bad. So here I'm just selecting the parts that I want the CNC mill to machine. And here you can see a simulation of the way that the end mill is going to remove the material on the guard. It's super important to simulate when you're doing CNC machining so you don't crash the machine, which can totally happen if you're not careful. And here's the good old Rad Lab logo. After all the CNC programming was done, it was time to move on to the real deal. And one of the first things to do is to carefully chop one of these aluminum bars with a chop saw. After the aluminum was prepped, I uploaded that sweet G code into the computer and started cutting away. It's crazy how many people think that the liquid squirting in the machine is milk, but no, totally not milk. Definitely coolant. Coolant's actually pretty important. When you have a good amount of coolant on the end mill will last a super long time, especially in aluminum or plastic. These particular parts were cut on a Tormach 440 and it did an awesome job, really clean parts. After the parts were done, I had to deburr them and clean them up a little bit. So obviously the logos were silver, so they didn't really pop out a whole lot. So I took a Sharpie and kind of colored them in just to help them have a little bit more contrast. And I think it makes it look a lot better. And here you can see me put a little bit of cutting oil on the sandpaper just so it doesn't get clogged so much with all those metal cuttings. A little machine shop tip for you. And after all that, the parts were looking freaking sick. I love the skeletonized look of the aluminum, and it helps save a little bit of weight. 2 birds with 1 stone. After machining the guards, I moved on to electronics. Here I started setting out all my electronics, and I just soldered leads onto all of the components. That way I could hook it really quickly into a prototype circuit. That way I could test my code on a fully built circuit. Also, this helps me if I find out that a component doesn't work or if I find something better, I can swap it out really easily, and I haven't committed to a design that holds all my electronics yet. And so that's really nice too. I had to move my circuit around a little bit, and I was showing a couple people my circuit, so I put it in this pretty sweet cardboard box. After the basic circuit was together, I started writing the code. For the main bulk of code that kind of controls everything, I ended up using what's called a state machine. And for the rest of it, I used a bunch of other nerd stuff. So if you want to hear more about that, shoot me a comment down below and maybe it'll be down there. Also, shout out to my boy Eric who helped me when I got stuck on a couple pieces of the code. Coding was super fun, and when I was doing this project and coding it up, I actually had some ideas for some other projects, so keep an eye out for those in the future. And when I was doing some of the code, I printed out some of the mounting boards for the electronics. I totally jacked up the location of some of the holes on one of them, so I immediately had to print another one, so that's what this one is. Some of the electronics and the polycarbonate covers are held down by these super tiny screws. They're size 80, which in normal English is just a super small screw. They are some of the smallest I've ever used. And to screw the screws into the plastic, I put in what's called heat set inserts. They're these little brass inserts that you see melted into the plastic. Super helpful. After all that was installed, I just put in the electronics just to see the fit, and this is kind of what it looks like. So everything looked really good with the electronics, so I just started to run wire to all the components. This part took a super long time and was really tedious. And whenever I do something that will take a really long time and is really tedious, I start an audiobook. And so that's exactly what I did here. So after everything was wired together, I tested it. I needed a little bit of recalibration, but after that, everything was good to go. And here you can kind of see that's what I'm doing. I'm just getting a sensor reading from the skateboard, and then I'm just changing an offset in the code to help it read correctly. So kind of one of the last things I wanted to do is to add some protection to the electronics. So I designed some polycarbonate plastic covers to kind of help keep like dirt and water and all that kind of garbage off of the electronics. And so I used good old Fusion 360 to design the cover and also to program the CNC cutting paths on my CNC router. And I slapped the code in there and cut them out. So after they were cut out on the CNC router, I used a heat gun to make the plastic soft, and then I bent them into shape using my hands. The parts were pretty hot, and it was definitely a good time to use gloves. I actually had a couple of mishaps here because I heated up the plastic a little bit too quickly, and when you do that, bubbles will form in the plastic, and it just looks really bad. And I actually had to remake them about 2 or 3 times before I found out how slowly I needed to heat up the plastic in order to bend it. And unfortunately, when I was testing the board, I found out that the wires actually broke off really easily, and that's just because the wires were too big. So when I soldered the wires on the first time, I just kind of used the wire that I had on hand, even though I knew it was a little bit too big, but I thought it would be okay. Turns out, totally not okay. So I ordered the right size wires a little bit smaller, and it could fit through the vias in the boards. Vias are those tiny little holes that electronics parts have, so you can fit wires or headers or jumper cable ends or whatever you want to solder into them. You can fit those inside those vias. So I ordered some smaller wire that fit correctly inside the vias, and I had to desolder all of the old wires that I bent previously, which was the biggest punch in the gut ever because of how long it took to make them. And then I resoldered and bent all new wire to make sure that it worked just the way it did before. Definitely glad I did this, especially with something like a skateboard that you know is just going to be thrashed around a lot. The next thing that I needed to do was generate all the voices for the seconds call outs. And for that, I went to a text-to-speech website called FakeU. FakeU is so cool because they have so many voices, and obviously I had to choose Rick Sanchez. But this is definitely a place I think I'll get a lot of really good voices for future projects. Pretty cool website. All you do is enter the text that you want it to say, hit speak, and it processes it and then provides a link for an audio file. I then organize those files into folders and then put that on a micro SD card, and then that went into the MP3 board. Okay, the skateboard works pretty good. I just turn it on using this little switch right here.
Hey Braille, I'm Skateboard Rick.
The light blinking rate is linked to the angle. So the higher it is, the faster it blinks.
4 seconds. Cool, that was 5 seconds. Nice, 10 seconds.
So it works pretty good. So I had fancy ideas about mixing wood glue and sawdust to kind of patch those holes, but at the end of the day, I was too lazy and just committed the cardinal sin of putting a sticker over it. So sorry about that, Braille. And because I'm a giant man-child, I had to put my own finishing touch on there, and the board was complete. Cool, and that's pretty much the whole build. I'll chuck this thing in a box and we'll send it off to him and we'll see how it does. Thanks for sticking around this long, and we'll talk to you guys later. Bye.